From recommending your next favorite show to predicting global weather patterns, artificial intelligence isn't just a concept from science fiction anymore. It's woven into the very fabric of our daily lives, often operating silently in the background, shaping our experiences. But what is artificial intelligence truly? Is it a super-intelligent robot bent on world domination, or simply a sophisticated piece of software? The answers are more nuanced, more fascinating, and perhaps more profound than you might imagine. Welcome to Orbit of Understanding, where today we're embarking on a comprehensive journey to demystify artificial intelligence, exploring its origins, its inner workings, its incredible applications, and the profound questions it raises for our future. At its core, artificial intelligence, or AI, refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. It's not merely automation which simply performs tasks according to predefined rules. AI goes a step further. It enables machines to perceive, learn, reason, problem-solve, and understand language, functions we traditionally associate with human cognition. Think of it this way: a traditional washing machine automates the laundry process, but it doesn't learn new ways to clean. An AI-powered smart home system, however, might learn your preferences, adjust lighting based on your routine, and even anticipate your needs. That's intelligence at work. A classic thought experiment in AI is the Turing test, proposed by Alan Turing in 1950. It suggests that if a machine can converse in a way that is indistinguishable from a human, then it can be said to possess intelligence. While debated, it highlights the ambition at AI's heart, to emulate human-like thought. The dream of creating intelligent machines isn't new. Ancient myths spoke of automatons and golems, and thinkers like Gottfried Leibniz pondered logical reasoning machines. But the modern concept of AI truly began to take shape with the advent of computers. The term artificial intelligence itself was coined in 1956 at the Dartmouth Summer Research Project. This seminal workshop brought together pioneers who believed that every aspect of learning or any other feature of intelligence could, in principle, be so precisely described that a machine could be made to simulate it. However, the turn of the 21st century saw a powerful resurgence. This AI spring was fueled by three critical factors: an explosion of available data, vastly increased computational power, especially with GPUs, and the development of more sophisticated algorithms, particularly in a field we now call machine learning. When we talk about AI, it's important to understand there are different categories, not just in terms of capability but in their very nature. Most of the AI we interact with today is narrow AI, also known as weak AI or artificial narrow intelligence. This type of AI is designed and trained for a single, specific task, and it performs that task exceptionally well, often surpassing human ability. Think of IBM's Deep Blue beating chess grandmaster Garry Kasparov, the personalized recommendations you get on Netflix or Amazon, the voice assistants like Siri and Alexa that answer your questions, or even the spam filter in your email inbox. These systems are highly intelligent within their defined domain, but they can't do anything outside of it. A chess AI can't write poetry, and a voice assistant can't perform surgery. The next level is general AI or artificial general intelligence (AGI), often called strong AI. This is the hypothetical AI with human-level cognitive abilities across a wide range of tasks. An AGI would be able to understand, learn, and apply intelligence to any intellectual task that a human being can. This includes reasoning, problem-solving in novel situations, abstract thinking, and learning from minimal data. Much like a human, AGI is still largely theoretical and remains a significant challenge for researchers, often considered a goal for the distant future. Beyond AGI lies super AI, or artificial superintelligence, ASI. This is an AI that would far surpass human intelligence in virtually every field, including scientific creativity, general wisdom, and social skills. ASI is highly speculative, often featuring in discussions about the singularity, a point where technological growth becomes uncontrollable and irreversible. While the idea of ASI raises both utopian and dystopian visions, it serves as a powerful thought experiment about the ultimate potential and responsibility of AI development. So, how does AI achieve these incredible feats? The primary way modern AI learns is through a subset called machine learning, or ML. Unlike traditional programming where every instruction is explicitly coded, ML systems learn from data. One common type is supervised learning. Here, the AI is trained on a dataset that is already labeled. For example, you feed it millions of images of cats labeled cat, and images of dogs labeled dog. The AI then learns to recognize patterns that distinguish cats from dogs, and can apply this knowledge to correctly identify new, unlabeled images. Then there's unsupervised learning, where the AI is given unlabeled data and finds patterns or structures within it on its own. This is useful for tasks like customer segmentation, where the AI might group customers with similar purchasing habits without being told what those habits are. And finally, reinforcement learning, where an AI learns through trial and error, much like a child. It performs an action, receives a reward for good outcomes or a penalty for bad ones, and gradually refines its strategy to maximize rewards. This is how AIs learn to play complex games like chess or Go, or how robots learn to walk and manipulate objects. A crucial development within machine learning is deep learning, DL. This is inspired by the structure and function of the human brain's neural networks. Deep learning uses artificial neural networks with multiple layers, often tens or even hundreds, to process information in a hierarchical way. These deep networks are incredibly powerful at recognizing complex patterns in vast amounts of data, making them excel in tasks like image recognition, natural language processing, enabling computers to understand and generate human language, and speech synthesis. The impact of AI is undeniable, transforming nearly every sector of our lives. In healthcare, AI assists in diagnosing diseases earlier and more accurately, from identifying cancerous cells and scans to predicting disease outbreaks. It's also revolutionizing drug discovery, accelerating the research for new treatments. In finance, AI algorithms detect fraudulent transactions in real time, manage investment portfolios, and provide predictive analytics for market trends. Transportation is being reshaped by AI, from optimizing traffic flow to the development of self-driving cars, promising safer and more efficient journeys. Customer service is increasingly reliant on AI chatbots and virtual assistants that can answer queries, troubleshoot problems, and guide users, often providing 24/7 support. Even creative industries are embracing AI, with tools that can generate art, compose music, or assist in writing, pushing the boundaries of what's possible. And in science and research, AI sifts through massive datasets, simulates complex systems, and accelerates the pace of discovery in fields from astrophysics to genetics. As AI becomes more powerful and pervasive, it brings with it crucial ethical considerations. Questions about bias in algorithms: if the data fed into AI is biased, the AI will learn and perpetuate that bias, are paramount. Job displacement is another major concern, as AI automates tasks previously done by humans. We also face critical questions about data privacy, who owns our data, and how AI systems use it. Beyond these, more philosophical debates arise. What happens when AI systems become truly autonomous? What are the implications of autonomous weapons? And how do we ensure that AI remains a tool for human flourishing rather than a source of unintended consequences? Despite these challenges, the overwhelming consensus is that AI has the potential to solve some of humanity's most complex problems, from curing diseases and combating climate change to driving economic growth and enhancing our cognitive abilities. The future of AI is not predetermined. It is being shaped by the decisions we make today. From the earliest dreams of intelligent machines to the sophisticated algorithms powering our modern world, artificial intelligence is a testament to human ingenuity. It's a field of constant evolution, pushing the boundaries of what we thought possible. As AI continues its incredible journey, so too does our orbit of understanding. Join us tomorrow for another exploration into the vast universe of knowledge. Subscribe to Orbit of Understanding and hit the notification bell to ensure you never miss your daily dose of insight. We'll see you then.